Thank you, Mr. Chairman. Dimitrios, first I want to congratulate you with your nice presentation. I think you were able to present complex things in a simple way, which is really nice. Maybe just one question. You pointed out that to understand forests, or to measure and to present forests in a more realistic way, there's a spectral challenge and also structural challenge. And you worked a lot with your PhD on the spectral challenge, but you said that maybe the main gap is still to measure forest structures in a more accurate way. But also there, your research group made a lot of progress. There was also the PhD of Dimitrios Biliouris, working with LiDAR and so coming to very detailed forest structures. But in your presentation you showed somehow that yes, LiDAR research and BRDF research could be linked somehow, but it was a bit vague how you would do that. Could you go a bit more in detail how both types of research could be joined now to come to, I would say, better, more realistic forest models?
Yes. In terms of visualization purposes, imagine that with a LiDAR scene or a LiDAR input, I will not have to use the map software, which is a software that simulates reality. And we're not, as stated, 100% that the trees are exactly real. So what can happen is with LiDAR measurements, I can work on an existing forest, measure the BRDF of the elements of the forest, and continue with the bark, the stem, and the soil, and then create a virtual forest that is actually the real thing. And in that virtual system, I can put all the possible orbits, all the possible sensors, sense a number of different wavelengths, and then have the proper geometrical and structural information that I would need to provide an accurate reflector signal as an outcome. So the idea is that to combine the two researches in a way with a given area. So focus on a specific area, on a specific species, measure that species with a LiDAR, that's done, and then put the input of the BRDF of that specific area.
Agree. So, and then the step to very accurate photosynthesis and transpiration measurement will be on a
time series basis. So if you have a specific research area, you can just repeat the same procedure of measurement and recreate the virtual forest A on the field, so measure with LiDAR every 2 years, and then see what has been changed. And then maybe use the link with the upper, with the radiance estimation, to see if your photosynthetical or your canopy growth model would provide the same result as the ones that you are currently measuring in the field.
Thank you very much.
Thank you, Professor Mez. Professor Popper, more questions? Are there questions from the public?
We all know that research work takes too much time, many years, and it's a quite isolating work. You are by yourself, and for the VPC and your dad. I'd like to ask you what I'd like to ask you all these years of research, what brought to you as Dimitri, as a scientist, and as a human of this society?
It's the $1 million question. Yeah. Well, as a person, I let others to judge it. So for people who know me all these years can see if I have changed or what brought to me, if I became better or worse. But on a personal experience, the scientific work and the research is a very challenging issue, especially if you are alone and abroad. You have to fight sometimes with your own self, to be more work-driven or solve a problem, not give up, and then interact with all the people that are involved in your research, which you definitely gain. From my promoters to my colleagues, I feel much richer as a person. And as a scientist, well, I said it in my acknowledgements, it might sound a bit too cocky, but the result, the feeling you get when you solve something of your research, after struggling to find why it doesn't work and why it doesn't work, and at the end you find a solution, it's incredible satisfaction. So that would be my answer.
Thank you. Are there more questions? to thank the members of the jury and the lady from the public for their interesting questions.